Hello, today we're going to be talking about the photoelectric effect. So what is the photoelectric effect? Whenever we have a metal that is negatively charged, or actually it doesn't even have to be negatively charged really, and we have photons incident on the metal, those photons will sometimes allow the metal to eject electrons. But the thing that makes this very interesting is the electrons can't be ejected by photons of low frequency. They can only be ejected by photons of high frequency. So what's actually going on here? Whenever we have photons, their photons are the particles of the electromagnetic spectrum. So we've got light in this little box here, UV, X-ray, gamma, infrared, microwaves, radio waves. So all of these waves are made up of particles called photons, but they're not really made up of particles called photons. They exist in a thing we call wave-particle duality, where these things here, gamma, X-ray, ultraviolet, visible, microwave, radio waves, are both waves and also particles at the same time. Sounds a bit complicated, but we'll get to that in another video. So these all have different frequencies. The high frequencies are gamma, X-ray, UV. In the middle we've got visible, then these are all low frequencies on this side. So the photoelectric effect can be observed in around this sort of region here, in the high frequency area. So what that means is we have the electrons that are being liberated for the metal are dependent on the frequency. So this can be formulated in this expression here, where energy is equal to Planck's constant times the frequency. So Planck's constant is constant in nature, and that's 6.63 times 10 to the minus 34 joule seconds. Frequency is measured in hertz or per seconds, and then energy is measured in joules. So if we have a metal, and all metals contain particles which have electrons, and all metals also have a work function which is given the symbol phi. So whenever the energy coming in is above the work function of the metal, then the photoelectric effect can be observed and the electrons can be liberated from the metal. So the way we formulise this is we say the energy minus the work function is going to be equal to the kinetic energy of the ejected electrons. So if we put energy into HF, then we know the frequency. You'll probably be given the work function of the metal. You wouldn't really, in general, have to learn any work functions of metals. So we'll call that just phi. And that's going to be equal to the kinetic energy, which is half times the mass of the particle times the velocity squared. And the mass of an electron is equal to 9.11 times 10 to the minus 31 kilograms. So thankfully, you'll be given these values in your formula sheet for the exam. But essentially, that is all. Those are all the sort of formulas that you need to know for the photoelectric effect. Oh, and there's one more thing, which is 1 electron volt is 1.6 times 10 to the minus 19 joules. Because often, rather than dealing in really tiny numbers like these all the time, we often just denote energy in terms of electron volts instead. So why does this not work for photons of low frequency? And that is simply because if E is equal to HF, then and F is small, then our energy value is going to be small. And if our energy value is not greater than the work function, then we will have no kinetic energy for our liberated particles. You can see this happening whenever we have a gold leaf electroscope. So we have our electroscope, which looks like this, and then we have a gold leaf attached to it in a vacuum. Be in a vacuum container here, and then we have a plate of metal, which happens for lots of metals, but zinc is the one that it's easiest to observe. So we get this and we negatively charge it just through using induction. So whenever this is negatively charged, the two sides of our gold leaf electroscope will move away from each other because they're like charged, and like charges repel. And then we have our light incident. So if we have red light, and red light is of a lower frequency, then you won't see anything happen. If we have ultraviolet light, which is of a bit of a higher frequency, we'll just do it in blue. If we have ultraviolet light incident on our zinc plate, then electrons will be liberated because the frequency of the light means that the electrons have the work function of the zinc, is able, there's enough energy in the light photons to liberate the electrons in the metal. So if those electrons are liberated, then our gold leaf electroscope becomes less and less negatively charged because we're losing electrons, and and we can visibly see it moving closer to the together, because they're not they're not, the charges aren't as repellent because they're not as negatively charged anymore. So that about wraps up the photoelectric effect. I've got a couple of videos of questions for it as well. All right, thank you.